Hi, this is Simon, and he's going to help me demonstrate two of Newton's laws. The first law we're going to demonstrate is Newton's third law, which is for every action there is an equal and opposite reaction. Now, see here. Basically, the force of Simon's weight is equal and opposite. Well, hold on, let me rephrase that. The force of Simon's weight on my arm is equal and opposite to the force of my arm holding him up. Kind of imagine arrows pointing towards Simon and then an arrow pointing up towards my hand. And that's Newton's third law of physics. Now, for Newton's first law, which is an object at rest remains in rest unless a net force is applied to move it, and an object in motion stays in motion as long as the net force, unless a net force is applied to stop it. Now, Simon is pretty much at rest right now. So unless he applies force to his muscles to get him to move, he's going to stay motionless. Now, I'm going to get him to apply force to his muscles where he'll constrict and be in motion. Or at least I hope he is going to. Come on, Simon. As you see, Simon's applying force and he's in motion, moving up my arm and probably to around my neck. Or not. Now, let's see here. I lost my place. Object in motion. Now, another way that can be demonstrated is a little bit too mean for me to use Simon for. So, I'm going to put him over here for now. This is Miles, and he's my stunt snake. He's been trained for this. And no snakes have been harmed in the making of this video. Now, like I said, an object in motion remains in motion until a force is applied to stop it. Well, if I drop Miles, he'll keep on falling until the force of the floor stops him. If there was no floor, he'd keep on falling. And he'd be falling at a constant velocity. Not velocity, acceleration. Ready? You see how he was in constant motion right up until he hit the floor? Force of the floor stopped him. Likewise, like I showed with Simon, an object at rest remains at rest unless a force is applied to move it. Like that. Now, our final law that I'm gonna demonstrate is Newton's second law, where force equals mass times acceleration. Now, something you gotta know about Newton's second law is that acceleration is proportional to force, and acceleration is inversely proportional to mass. Now, what that basically means is that the more force that is applied to an object, the more it will accelerate. Likewise, the less force you apply to an object, the less it will accelerate. And the more mass an object has, the less it will accelerate. Or the less mass an object has, the more it will accelerate. Now, to demonstrate that, I'm going to use my books. Now, this book has a fairly small mass. So it should accelerate faster. Or easier, at least. I can do that with one arm. It didn't need much force to accelerate. But if I tried to do that with a lot more books, which would equal a lot more mass, it'd be harder for me to move them. The acceleration will be low. See, it takes two arms and I still struggle to lift them. And that's because these books have more mass. So, more mass, less acceleration. Acceleration is the movement, so the more mass, the harder it is to move it. The least amount of mass, the easier it is to move it. And that's Newton's 3 laws.